This is the homework for 4.2b. We're going to try to move just a little bit quicker on this one. If you need more in-depth explanations for these problems and having them done a little bit slower, you should probably go back to the first video, which was 4.2a. Alright, number 1. It asks you to identify the vertex, axis of symmetry, max, min value, and the range. So we're going to use the fact that the vertex x-coordinate is located at the opposite of b over 2a. So the opposite of b, which is 2, divided by 2a. Remember, a is 1, b is 2 in this problem. We're going to have negative 2 divided by 2, which is negative 1. So that's your x-coordinate of the vertex. To get your y-coordinate, we're going to substitute negative 1 in for x. So we'll do that. Negative 1 squared is 1. 2 times negative 1, negative 2, plus 1. 1 minus 2 plus 1 is 0. So there's your vertex. The axis of symmetry is x equals h, so x equals negative 1. The max-min value, the a is positive, so it's going to open up. That means it's going to have a min value. And that min value is 0. It's always the k value. And the range, it's the set of all y's such that y, it opens up, remember, so it's greater than or equal to the min value. And that's it for number 1. Number 2, same questions. So the opposite of b over 2a is negative 2 over negative 2, which is 1. So the vertex is going to be 1 comma something. So we're going to have to plug in 1 up here and see what we get. Use parentheses when substituting. So y equals 1 squared is 1. 1 times a negative is negative 1. Plus 2 plus 5. 5 and 2 is 7. 7 minus 1 is 6. So there's our vertex. Axis of symmetry, x equals the x-coordinate. The max-min value, it's opening down, so it's going to have a max value of 6. And its range is going to be the set of all y's such that y is less than or equal to 6. It's less than or equal because it opens down. Same thing on this one. Opposite of b over 2a, 6 over 4, which reduces to 3 halves. So that's my x-coordinate of the vertex. So we're going to plug in 3 halves for x. Here and here. Three halves squared is 9/4. Minus 6 times 3 halves is 18 halves, which is 9. 2 times 9 halves is 9 halves. Sorry, 2 times 9/4 is 9 halves. Minus, I'm going to convert these to halves just to make it easier. And then add all those up. 9 halves minus 18 halves is negative 9 halves, plus 6 halves is negative 3 halves. So that's your vertex. The axis of symmetry is x equals the x-coordinate. It's going to have a min value since it opens up. min value of -3/2, and its range, since it's opening up, is the set of all y's such that y is greater than or equal to -3/2. This is a greater than sign here. Alright, number 4. Asking you to graph this. When graphing, it's always key to get the vertex. So the opposite of b over 2a. That comes out to be -3. So the vertex is going to be -3 comma something. So let's plug in -3 here. So y equals -3 squared plus 6 times -3 plus 9. That's 9. That's minus 18. That's plus 9. 9 and 9 is 18. 18 minus 18 is 0. So my vertex is going to be right over here. I can also plot the y-intercept, which is 9. So I'm going to plot that there. Now for symmetry, that is 3 units to the right of the axis of symmetry. So I'm going to plot a point here 3 units to the left. So then I'm just going to connect these, and there's my graph. Alright, number 5. Write it in vertex form. So we're going to want to try to find the vertex. So again, opposite of b over 2a. You're starting to notice how important that is, the whole idea of the x-coordinate being located here. It's extremely important. So we have 4 over 2, which is 2. So the vertex is going to be located at 2 comma something. So let's plug in 2 and see what we get for an output. So y equals 4 minus 8 plus 6. 6 and 4 is 10. 10 minus 8 is 2. So that's my vertex. My a value is 1. So if I have my h, my k, and my a, I'm just going to stick this in vertex form. So y minus k equals a times x minus h squared. And that's your answer. Number 6. The vertex is given. Find the unknown coefficients. So again, we're going to work off the fact that the opposite of b over 2a equals my x-coordinate of the vertex, which is 3. Now, do I know a or do I know b? I don't know b, because it's right over here, but I do know a. It's the coefficient of x squared, so I know it's going to be 1. So the opposite of b over 2 times 1 equals 3. Multiply both sides by 2, so b is -6. Now I know b. I'm just going to stick that in there. What I'm going to do is I'm going to stick 3 for x and -4 for y, and then solve for c. Minus 18 plus c. -4 equals -9 plus c. Add the 9 to the -4 and you get 5 equals c. So here and here are my unknown, well, they're now known. Those are my coefficients that were unknown but are now known. Number 7 is a review problem. Choose the method that seems easiest to use. Solve the system. So what I'm going to do is I'm going to multiply the top by 2 and the bottom by 3, so that I can get 6x on the top and negative 6x on the bottom, so that when I add down, they'll cancel. So when I multiply the whole top by 2, I get 6x minus 10y equals 52. On the bottom, I'm going to have negative 6x minus 9y equals negative 33. So when I add down, the x's cancel, which is what I wanted. I'm going to have negative 19y equals 19. 52 minus 33 is 19. Divide both sides by negative 19, I get y equals negative 1. So what I do now is I can choose to stick in negative 1 for either this y or that y, and then just solve for x. I'll plug it in the top one, use parentheses when substituting. So we get 3x plus 5 equals 26. 3x equals, subtract 5 from 26, you get 21. Divide by 3. Write your answer as a coordinate. It's a point, x comma y. 7 comma negative 1. Because this implies that the answer to the system is the point of intersection, 7 comma negative 1. Alright, number 8. The answer is going to be the equation of a line that's perpendicular to this. So the perpendicular slope is going to be the opposite reciprocal of negative 1, because there's my original slope. The reciprocal of negative 1 is negative 1. The opposite of negative 1 is 1. So the slope of my new line is going to be positive 1. So if that's my new slope, and here's my point, I can just stick it in point slope form. So y minus y1 equals my slope times x minus negative 1. And that's my answer. Write the equation of a line that passes through the 2 points. We're going to find the slope first. So y2 minus y1, watch out for the double negative, divided by x2 minus x1. 6 minus negative 1 is 7. Negative 2 minus 5 is negative 7. So my slope is negative 1. I can have 2 answers here, depending on the point that I choose to put in point slope. So y minus negative 1 is y plus 1 equals the slope times x minus 5. That's acceptable. Or, if I use the second point, y minus 6 equals negative 1 times x minus negative 2, which is x plus 2. And the last question. Write out an explanation describing how the minimum or maximum value is related to the range of the parabola. Well, if it has a maximum or minimum value, the range is going to be different. If it's a min value, then the range is going to be the set of y's such that y is greater than or equal to the min value. And the reason why is because if it's a min value, it bottoms out. So if you're looking at the outputs of something that bottoms out, the min value is the very lowest that it goes. It goes to infinity after above that point. There's no limit to where it goes. So y is going to be everything greater than or equal to that min value. But if it has a max value, that means it opens down, meaning it tops off. So y is going to be everything less than or equal to that max value. So whatever that max value is, that's where you would write it. But this video was a lot quicker than the other one. The other one was 26 minutes or so. Granted, I talked about how awesome I was at drawing butterflies for 25 of those 26 minutes, but this one's only 15 minutes. It's a lot quicker. If you need it slowed down, either pause the video and work it out, or if you want to hear a more detailed explanation, re-watch the first video until you really understand the concepts. This video is quick because I'm assuming that you already know the concepts, and we're just showing you how the problems are done, more of the arithmetic than anything else. And that's it.